and this is Mr. Watlington. Welcome to Systems Analysis and Design. This should be a pretty exciting class. I'm really kind of excited to teach it, especially some of the material, because it's a learning experience for me also. Now, let's get into what I'm going to provide today is just a brief overview of what we're going to do for the next 8 weeks, and you're going to go much deeper into each of these topics. But this is just a broad overview. We're going to look at some things such as the major topics. And when we think about this course, it's broken into 3 major areas: systems analysis, system design, and program management. Now, within those 3 large areas, there are some course goals, and we're going to go through each of these goals. Now, like I said, when we look at these goals, we're talking about, there's 9 of them, and we're going to go through each one of these, so I'm not going to read them right here. Now, I will make these slides available on the website, also on Blackboard. Okay, let's take a look at what we got. The first goal of this class is really we're talking about systems analysis and design. And there are 2 separate things. That's right, 2 separate things. When we talk about systems analysis, this is talking about the what is required for a new system. Because evidently there's a problem to be solved. That's why we need a new system. So now we have to capture with analysis what that problem is and what that new system needs to do. Now, when we talk about the design phase and the system design, that's the how the system is going to operate to solve the problem. So design, analysis, 2 separate functions. Even though we throw them together, we kind of crunch them together here. Now, we look at our second goal. Really, it comes down to how you gather system requirements. And this is probably kind of the heart of system analysis and design, because if you don't get the requirements right at the beginning, many times you're going to be stumbling the rest of the project. Now, when we think about this, it's really kind of there's 6 core processes that's associated with system requirements and how we go through this function. You have to identify the problem, and then also obtain approval. Especially if you're in any type of organization, you're going to have to obtain approval once to go forward with your project. Plan, monitor the project, discover. You need to understand the details of what's going on, know how to design your system components, and then you do the build test, and finally you do a complete system test, and you deploy the solution. Now, within each of these 6 processes, we have iterations. If you look at these 6 iterations, at iteration 1, like I said, your identify is really the big thing, and all the way down through to iteration 6, that's where you see that now you're deploying and doing the systems test. Now, also when we talk about gathering system requirements, and this is critical right here, is what we call the FERPs, or functional and non-functional requirements. There's 2 different types of requirements: functional requirements, non-functional. Now, when we think about functional requirements, just like it says here, your functional requirements are things that system has to do, how it's going to process information, and how it's going to fit the business rules of the organization that you're in. That's the functional. Now, and we have that's how we come up with this little term up here, what we call it, FERPs, functional, usability, reliability, performance, and security requirements. Now, your non-functional requirements, that's the rest of it. That's the usability, reliability, your performance, and security. Now, these non-functional are different things like your user interfaces, failure rates, what type of encryption you may going to use on your system, different types of access control, response times. So these things that kind of separate those 2 in your mind. Functional is the hard core requirements of what that system has to do. And your non-functional is those other things related to it that says this is how it needs to do it. This is how quickly I need to be able to restore or recover, or this is how we need to secure it. Functional, non-functional. Now, when you gather requirements, one of the first things you really need to understand is who are your stakeholders. And really, when you look within your organization, because your stakeholders are key to the requirements process, especially when it comes to vetting requirements. And within any type of organization, any type of business, you generally have 2 categories of stakeholders: internal and external. Now, I say internal, these are individuals who are internal to your organization, and then you have external stakeholders who are from partner organizations, like your customers. Customers are stakeholders also, but they're your external. Now, internal would be people like auditors, bookkeepers, all those types. Now, within these 2 areas, we have operational stakeholders, and then we have what we call executive level stakeholders, like your senior managers, your C-staff, the CEO, the CIO, the COO, board of directors. And then from the external, you also have executives. These are investors and regulators. I mean, so any business operates within some realm of regulation. So when we think about gathering system requirements, we have to be sure that we integrate and interface with all these different sets of stakeholders, whether they're internal, whether they're external, if they're from the operational side of the house, or if they're from the executive side of the house. So now that we've made all these touch points, it comes down to now really how do you start gathering information? Many different ways. This is just some that we'll discuss in this class, where everything from how from interviews, really where you go out and you talk to customers. Many times organizations will bring in external consultants really to do this, where they will come in and interview people, because a consultant who is a third party, they're kind of a disinterested third party, so they're not biased in any way. Also, questionnaires. You can distribute questionnaires. Is that the best way? It works, but sometimes you don't get the best information back with questionnaires. Reviewing your input and outputs and documentation, meaning that what is the raw material you bring in, what do you produce, and what goes out the other end? And what are the processes associated with that? Because your system has to be able to interconnect and interleave with that. Also, observing your business processes. Really, that's a big part. Really, to step back. Here again, sometimes a third-party vendor is good at that, because they can step back and look at your organization holistically and see from really at a bird's eye view what your organization does. And especially with our web internet connectivity now, we're able to get a lot of user comments and feedback. And the little stars, 3 stars, 4 stars, 5 stars. All of these are just methods of gathering systems information. Now, another way we gather system requirements, another part of this is with models. Okay, so because once we gather this information, we have to be able to put it in some type of form that's not abstract, that we can actually start making decisions with it. And we do this with a model. And when we think about models, no different than a model car or a model plane or a model train or whatever it may be, it is just a representation. That's all a model is, a representation of some aspect of a system, or maybe even a subsystem, depending on how large your system is. Now, different types of models. 3 types of models that we're going to talk about in this class, what we call textual models. That's when you write it down, describe it. You got graphical models, diagrams, schematics, things of that nature. And there's mathematical models. Mathematical models, like I said, that's formulas, different types of like statistics or algorithms. All of those are models. Now, one type of model that is used quite a bit, especially with expressing from a graphical perspective of how systems fit together, is UML, the Unified Modeling Language. And what UML does is it gives you a standard set of characters similar to this class diagram model you see here, but a standard way of representing your model that's just kind of an industry standard. Like I said, so when we think about models, and we think about these, like I said, all different types. Like I say, you can have event lists, use case diagrams, location diagrams, many different types of ways of representing your data, and representing sequence flow, and representing activities flows. All right, also, now, we go to goal 3. Goal number 3 is what we call use cases. Because now I've got my data, I've got some type of flow. Now I need to set up some type of a use case. Is how does this operate within our environment? So what is the use case? Use case is an activity that the system performs, usually in response to a request. Now, the way that I like to approach use cases is kind of with what I call storytelling, telling a story. So when you look at a single use case, it should read like a story. So for instance, you see this diagram of a shipping clerk who has to ship items. Well, we can tell a story with this. What do I mean? As a shipping clerk, I want to ship items so that there is no backlog exists. So that way, now I can start breaking down exactly what, within this use case, what I need the system to be able to do. It needs to be able to allow the shipping clerk to do a function that will give some type of output, which is ship items and reduce backlog. So now, when we think about identifying use cases, there's 2 different types we're going to talk about, is the user goal technique and an event decomposition technique. I'm not going to get into that right now. And when we do use cases, we always want to name our use cases. Now, key to naming a use case is using what we call the verb-noun association. For instance, in this model we use here, I would name that ship items. Verb, ship. That's the action. The noun, items. So that way, now when you get hundreds, sometimes thousands of use cases, if you start naming them right at the beginning, that makes it much easier for you to keep up with them, to be able to catalog them, to be able to search, to be able to identify, and be able to extract them later on when you need them, just with a good naming convention. So when we look at step 4, or goal 4 of this class, is looking at different approaches and methodologies to system development. There's many different methodologies, and really it comes down to really 2 functional types, predictive and adaptive. And when we think about those, a predictive, that's when your requirements are well understood. Very low technical risk. You know, for years and years and years, especially in the industrial side of the house, requirements didn't change a lot, you know, and it wasn't as dynamic as it is now when we think about software and technology-based systems. So that's why we've moved from this predictive environment quite a bit, especially with software systems, over to the adaptive model. And that's where your requirements are uncertain or they change constantly, and there's a lot of high technical risk. So when we think about the software development lifecycle, SDLC, that's what it stands for, software development lifecycle, just remember that there's 2 ways of looking at that. So one of the models that we use is called the waterfall. And when we take a look at this waterfall, and then waterfall is really from the predictive era, because this is a set way of doing system development, where it takes these 6 steps, you know, your project initiation, project planning, analysis, design, implementation, deployment. Those are the 6 functional steps to system development. And one leads right into another, just like a waterfall, just kind of cascades down. Now, this works great when you are working with very static systems. Like I said, the requirements doesn't change much, not a lot of risk, because now you can go from one step to another. Problem with this is that it takes time. You know, this could be 3, 4, 5 year project. If you're working with software, if with information systems, nobody can wait 5 years to have a system fielded. By then, technology has changed, and by the time it hits the field, it's already outdated. And also another problem here is a challenge with this is that if something happens here at step 3, there is no real good feedback mechanism to make changes back to step 1. So that's why that model is a very good model, but we've moved into other different types of models. For instance, like Agile. You're going to hear a lot about Agile. And what Agile, here again, it's really a philosophy. It's not really something hard and fast, but it's more of a philosophy to where you only build the necessary models as useful and the right amount of detail. And so Agile is really more of an iterative approach of how you maintain agility in your system development process. Another model, as far also that is more adaptive, is the unified process, UP. Now, what the UP process does, it takes those basically those 6 traditional steps, and it really boils them down into 4 basic steps, where you have inception, elaboration, construction, and then transition. And within these elaboration and construction steps, that's where you have your iterations. That's where you have your repeating cycles there to ensure that you build in quality and that you meet the requirements in a timely fashion. Now, the extreme programming, XP, extreme programming, and this is a very interesting model. It's really based on 3 circles, kind of inside of each other. And really the goal here, we're not going to go through all this circle because we're going to get deeper in the class, but is that you start the process and you start doing the development, and quickly, as soon as you are at a point of release, of inception, you want to go ahead and release that product. Get it out to the customer, get it out there as quickly as possible, start getting feedback, and then work your way down to get another release, and work your way down that circle to get another release. So you're not holding on to software until you get everything completed. You just want to start getting those packages out there and making that way you can make updates, make changes to releases as they come about much quicker. Another one that's become very popular is what we call Scrum. Scrum is very similar to Scrum. I'm sorry, right here is very similar to the extreme programming process, whereas a Scrum, they have what they call sprints. And what a sprint is here, you start off where you got your product owner, and then you go into a quick cycle to where you build, get software out, comes back, you do another sprint. These may be short 30-day sprints where you just jump right in and you put the whole workforce on it, and you sprint, get that part of the package out, flips back around, put it back into development phase, but you're always still tied into your product owner or user owner requirements with that. So those are some of the different approaches, whether you're on the predictive end where things are stable, or if you're over here, on the adaptive end where things are very where they change quite often. So was goal 4. Let's look at goal 5, planning. Planning and project management. Really, at the end of the day, when we're talking about system design, system analysis, it really does come down to project management. Huge part of project management is the body of knowledge, PMBOK. If you've ever, studied to get your project management certification, your PMP, this is a book of or a set of rules that I'm sure you're probably already aware of, the program management body of knowledge. And what that body of knowledge does, it gives you expertise in looking at factors that may cause a project to succeed or fail. But also it gives you responsibilities of what a project manager does. Gets into some of the agile approach to project management. Just like the agile approach to SDLC, there's also an agile approach to project management, to where you can sprint, where you can get those cycles turning quicker and quicker. So that's really what Goal 5 is, and there are some assignments associated with Goal 5. Goal 6 takes us to object-oriented design. Now, what object-oriented design is where, where you bring your models together, all the way from your analysis models, your design models, all the way now to your programming models. Because in some of the other methods, we would do the analysis, even do the design. And that documentation, a lot of information, a lot of those models would then stop. And now when the programmers got it, they were pretty much starting kind of over from scratch. But this way, you have continuity between all those models. So now you're using the outputs of your design and your analysis models as objects, and you are able to describe them as objects. That makes it much easier, much quicker for your programmers to program, because now they can look at these things as objects and program in a modular fashion based on the use cases, based on the designs. Within this class also, we're going to talk about databases and some of the things that goes along with databases. When you think about a database, here again, it's just a collection, of information. It's really a collection of application, schemas. When I say schema, that's just a schematic or a way of representing your data. And then all of that has to be tied to some type of database management system, DBS. When you think about a DBS, think about SQL or Oracle or even Microsoft Access, And what those packages allow you to do is to be able to do things like standard structured query languages, where you're able to go in and query data, write queries, and extract the data that you need out. So whenever you look at a database, like I said, we're going to look at the different aspects of databases, whether it's rows, tuples, records, and all the different aspects, the different values, the different attributes associated with databases. Then we'll move into relational databases, and what a relational database is now where I'm able to relate data from multiple sources, bring it together, as long as I have some type of common field, some type of sort field, or an attribute in a field, key field, I'm able to link these together, and I'm able to bring together relationships, such as many-to-many, one-to-one, one-to-many types of relationships or associations, as well as distributed databases. Now, distributed databases are getting more and more popular, especially with web-based applications, where part of my data may exist in one location, part of my data may exist on other systems, and I need to pull data from multiple places and to be able to do multiple or parallel processing at these different locations, instead of having all my database management in one location. Also, within Goal 7, we're going to talk about testing, because one of the things you always want to do is, as you're developing a new system, you want to be able to test it. Many different types of testing, about 4 we're going to talk about here. Unit testing, that's where you take a module or a component of software and you test it as a unit. Now, if you test the units, you want to do integration testing. Even though this module may work by itself, how does it work when I plug it in with other modules coming from other places? So we always want to be sure that we do integration testing. I think I just lost a light. I did. Oh well, no problem. We're going to press on anyway. Now, you also want to be able to do system or stress testing. And what that is once I bring everything together, how now do I see if it's able to operate in a functional and meet the functional and non-functional requirements. What happens when I overload it? Does it, from a security perspective, if I input too much data, what we call fuzzing, if I input too much data, what happens? Does it fail safe? Does it fail secure? Is it able to isolate itself? And then at the end of the day, we have to do what we call user acceptance testing. As a user, there's parameters you want to be sure that it meets the functional requirements, the non-functional requirements, so that as a user, it is able to pass that test as well. Goal 8 takes us to things we need to do to make our system operational. So we've got it built, we're ready to deploy it. How do we make it operational? Well, really, it starts at the top with training. Because if we deliver a system and our customer, our user, our operators are not properly trained, then we failed. We have failed. Also, we want to be sure that we configure the system for the production environment, because many times when we're developing a system in a developmental environment, many things are, we have back doors open, especially if you're a software programmer. You haven't closed all the back doors. We haven't hardened the system. We haven't applied many security controls that should be provided in that environment. And then we need to make sure we plan and manage the production, because now we have to. There's maybe parts you have to mass produce in a production environment to make it operational. Two areas that was always very interesting and sometimes very challenging is how do you manage the source code? So let's say we've developed a software system in-house. Managing that source code, protecting that source code, making that source code available. How do you do updates? And that takes us into version control, because you know there's going to be updates. Without a doubt, anything written with software, any software written is going to require updates at some point. So how do you do version control? Version 1, version 1.1, version 1.1.1, and when do you go to version 2 or version 1.2? And there needs to be a methodology, a mindset of how that happens with your system. All right. Now, Goal 9. I love Goal 9. I love teaching for California Baptist University because of this. We get to integrate biblical principles into our lessons. And for me, that is just awesome. I love it. Now, if we look at, I love the book of Daniel. Because if you look at Daniel, he was taken into captivity by King Nebuchadnezzar, and he stayed in Babylon his entire adult life. But unlike many of us, if we were taken prisoner into a country and given a job to do, would we do it to the best of our ability? Probably not. But Daniel did, and he was able to integrate his biblical principles, his godly knowledge, into the day-to-day administration of a kingdom for a pagan king. And to me, that is so impressive. And Daniel chapter 6, actually, if you really just read verse 1 through 5, but I just pull verse 3 out of the middle. It says, "Now Daniel so distinguished himself among the administrators and the satraps by his exceptional qualities that the king planned to set him over the whole kingdom." When we apply our biblical, our Christian values, our godly principles, when we apply Jesus to our day-to-day life, not just on Sunday in church, that's pretty easy to apply there, but day-to-day in the marketplace, in the workplace, that is when we really see great changes. That is when, the Daniel in us starts to come out. Now, during this course, like I say, a lot of our discussions and things are going to be from some short video sessions, series that I've recorded myself, actually, called Messages in a Minute. And our discussions are going to be how you can take these concepts and principles from some of these short videos, and I'd like to hear how you can apply these concepts not just into your spiritual walk, but your daily walk. And really, those should be the same walk, right? We should be walking spiritually every day on a daily basis. But so as we integrate biblical principles into system design, system analysis, this is how we're going to go about it for this class. Is these things we call messages in a minute. I've already got them loaded into the syllabus, into the website. So I hope you enjoy them. Looking forward to this class, guys. Looking forward to it. Now, we culminate this class with the capstone project. And really, this project, you're going to be working on it throughout the class. So it's an iterative project that you're going to just build as we work through each of these goals. So what this capstone project is, like I said, it's an 8-week-long project consisting of a systems analysis, and there's some design for a typical information system. Like I say, the purpose, it's like I said, it's here on the screen. The purpose of the project is to perform a simulation of system analysis and design via a case study. We're going to be using a case study to make this happen. There's 3 things that will need to be submitted. 3 things. How many? Yes, I heard you say it. 3 things. First, you're going to submit a draft, a rough draft. Also, there will need to be, after the draft, a final report. That final report is going to be 12 to 18 pages, and be sure that you use your APA formatting and all the things that you have learned along the way at California Baptist University when it comes to submitting papers. And the third thing is a PowerPoint presentation with a minimum of 23 slides. So those are the submissions. Now, the thing to remember, this is a critical, that's why I put it in bold, critical assignment for this course. and you have to get a C or better in order to pass the course. So this capstone, like I say, that's your swan song assignment for this course. All right, guys. Again, I'm really looking forward to this class, this term, this 8 weeks. I think we'll have a great time. If you have questions, please don't hesitate to contact me via email. I've got my phone number, my cell number on the website and Blackboard as well. So looking forward. God bless you. Take care.